We see it every day. Birds casually resting on high voltage power lines that carry enough electricity to power an entire neighborhood. It looks like they are defying the laws of nature, but in reality, they are perfectly following the laws of physics. To understand why they stay safe, we have to look at how electricity moves. Electricity is always looking for a way to get to the ground. It travels through materials that allow it to flow easily, which we call conductors. The copper or aluminum wires on those poles are incredible conductors. Now, a bird's body is also a conductor, but it isn't nearly as good as copper. When a bird sits on a wire, the electricity is faced with a choice. Should it stay on the smooth, easy metal highway of the wire, or should it detour through the bird's body? Because electricity follows the path of least resistance, it chooses to stay on the wire, bypassing the bird entirely. But the real scientific secret is something called electrical potential. Think of electricity like water flowing down a mountain. Water only moves if there is a difference in height, from high to low. Electricity works the same way. It only flows if there is a difference in voltage. When a bird lands on a wire with both feet, its entire body becomes the same voltage as that wire. Because there is no potential difference between its left foot and its right foot, the electricity has no reason to move through the bird. It's like a boat floating on a river. The boat is at the same level as the water, so it just sits there. Humans get an electric shock when touching live wires because the body acts as a conductor, completing a circuit that allows electricity to pass through, often flowing to the ground. The human body, being mostly water and salt, offers a path of low resistance for electrical current to travel, causing muscle spasms, burns, or pain. The birds aren't wearing a tiny rubber boot. They aren't immune to electricity. They are simply staying out of the way of the flow. By touching only one point of potential, they remain a dead end for the current. It's a brilliant example of how, in the world of physics, being well connected isn't always a good thing. Thank you, and meet you again with yet another episode of Science Behind It.